This is the third try. Want to give you a few problems to look at that were similar to your take-home quiz, so I can provide any assistance because I know it's been a long weekend and maybe you procrastinated, but I just wanted to help out. All right, so if I could find my pen, we'll get started. This was your take-home quiz. So I wanted you to do 15 and 16 on the AP packet. Let's talk about those problems. All right. Here's 15. All right. I've got it detailed because it says we're approximating the area under the curve from 0 to 24. Okay. Of the rate. So we're doing a midpoint Riemann sum. So I've got it breaking up because it says I want 4 subdivisions. That's 4 subintervals. Same thing. Okay. So I divide by 4. I get 6. All right, so each of these are 6 in, each of these rectangles will be 6 in length. So basically the x's start at 0, then 6, then 12, then 18, then 21. Okay, so for midpoints, you basically need to understand that you're not using this or this, because if you were to start there, that would be a LRAM. If you were to start there, that would be a RRAM, okay? So you have to figure out what the midpoint is based on your notes. Now, another thing that you can do is start writing these a little more tastefully. This is an approximation, so we can actually set up an approximation sign right here. And all I'm looking for is that you try to use good notation, because this is I minus 0.5 because it's midpoint. And then, I probably won't take off if you don't do I minus 0.5, but y'all, try to use good notation, and then figure out what those rectangles are. Okay, that's it for 15. All right. For 16, here's 16. So you want to approximate from 0 to 50 with a Riemann sum using midpoints. So 0 to 50, and you want to use 5 subintervals. So basically this is the same situation, but you could like draw your rectangles on the graph, or you could think of this as just a sideways table. Okay, well here actually that would be sideways. That would be sideways. Oh geez. That's vertical. Yeah. Yeah, just think of this as a vertical table and you should be fine. Okay? And like I said, try to be tasteful, use the right units, use the right symbols, and whatnot. Okay, so that's my review of 15 and 16. Hope you got it done. Hope you did good. All right. Next we have, all right, these I wanted you to do in grade. Okay, so what I did is instead of using the square root of x, which is going to give you a lot of decimals, I'm going to use a different function, and I'm going to do problems the exact same but different function. So basically it helps you. Now if you like tables, I'm not using tables, okay? I'm using the regular notation. I don't like the tables, and I'm not using those crazy formulas either. We're just basically finding out the area, okay? Base times height, or whatever it is. Okay, so let's start with number 2, RRAM. I've got these backwards. Let's see. So, starting with number 2, RRAM, we have f of x equals x squared plus 3, so here's what the graph looks like. I know, don't laugh at me. We're estimating the area under the curve from 0 to 5 with 5 subintervals, same as the quiz. So basically your delta x is how many rectangles it divides up into, which is 5 rectangles, but the distance is 5 divided by 5 is 1. So that means we basically know each of these rectangles, and I'm writing in pen so you can see, each of these rectangles are 1 unit wide. That's what the delta x means. Okay, but y'all know that. All right, so we're going RRAM, so these rectangles are going to hit on the right and go over. You can fast forward through this. All right, good. So also I have n. I didn't explain that. Remember, n is just the number of things you're adding. Okay, and I don't know why I put 4 because it's 5. Jeez Louise, what's wrong with me? 5. Let me change that. Oh, I have it right there. Next is our notation. Okay, what is the RAM going to look like? Okay, so well, basically we're using this guy, this guy, this guy, and this guy, and this guy as x's. So it hits on the right, hits on the right, hits on the right, hits on the right, hits on the right. Well, the sequence of I starts at 1, so we're good. We're just going to write a plain old f of x of I, and that's it. Okay. Now, of course, we're going to multiply it times the base, height times base, height times base, height times base. So the delta x. Now the rest of these, I'm going to start moving through quickly because this is a review, and I just wanted to show you these problems. So here we go. Height times base. So the first height, 1, plug it in. What is that? 1 squared plus 3, 4. Times the base, 1. Plus 2 squared plus 3, 7. You can fast forward through this. All right, 3 squared plus 3, 12. No, 3 squared, yes, 12. And then 4 squared plus 3, 19 plus 4 squared, 16 plus 3 is 19. And then 5 squared plus 3 is 28. Okay, now all these ones don't matter, so it's got to be 4 plus 7 plus 12 plus 19 plus 28. There's always cool patterns. So 11, 31, and that's just 28, but I bet you it would be like something like 61 or something. On the AP exam, you have to write all this all the way out every time, unless I'm gonna write somebody an email to see if you have to write this out every time on the AP exam. I'm not sure. Okay, so 42, 28, 30, 70. Yeah, 70 units squared. Done. Okay, so basically, you draw your graph, you find out, okay, it's R, goes up on the right, goes up on the right, goes up on the right. Use the right notation. You have to memorize RAM as x of I. And then go about your business of plugging in, multiplying, base times height. All this is the height, that's all, and the base. Alright, so I'm going to move faster. I'm not going to do explaining because y'all probably just fast forward through it. Okay, so here we have an MRAM. Okay, the function is still the same. I didn't write it down. X squared plus 3. Okay. By the way, this is just for your own benefit. You don't have to watch this. So I'm just gonna. This is so you can know what to do on your take-home quiz, which you already should. All right. So 5 to 8, 3 subintervals. So let's go ahead. We'll calculate our delta x. It's 1, n is 3. So 5 to 8. This is what we're working with. X sub 0, x sub 1, x sub 2, x sub 3, and then we got a L, is this, well, I'm doing MRAM. I skipped the MRAM, sorry. MRAM, whoops. So we're actually going to go up in the middle, and we're going to stop where the middle hits. Okay. Okay, so remember this is actually x of 0.5, x of 1.5, because it's halfway, x of 2.5. Okay, so we're using those 0.5, so it's actually x of I minus a 0.5, minus 0.5, minus 0.5. You got a minus, you got a minus, you got a minus. Okay, all right, so f of x sub I minus 0.5 times delta x. And we have delta x, it's 1. Okay, so we just got to figure out what all these are. And so that's basically 5.5 squared, 6.5 squared, and 7.5 squared. So Let me go ahead and calculate all those. I'm just being lazy. I probably should have done it in advance. 5.5 squared squared 30.25. So the first height is 30.25. The base is still 1. And then 6.5 squared. 6.5 squared. 42.25. Wait, I forgot to add my 3. I always do that. Well, anyway, let's just scratch this line out. So that's actually 33.25 times 1 plus 42.25 plus 3 is 45.25 times 1 plus 7.5, so 7.5 squared. Alright, so 56.25 plus 3 is 59.25 times 1. Okay, so there we go. Alright, so we'll add all those up. And so that's 33 and 45 makes 78.5. So that's, whoops, yeah, 78.5 plus 59.25. Okay, yeah. And so 25, 75. So I'm just going to have 0.75 at the end. And then 9 and 8, 17. 70 and 50, 120, 137, if I'm not mistaken. So let me write that better. 137.75 units squared. There we go. And it's all from getting the midpoint. Cool beans. All right, and this is basically, I need you to show this work. This work right here. Show the work. Show the work. Let me circle that. All right, show the work. Can't do a smiley face. Yeah, there we go. So moving on. Now we're at number 3, the LRAM. So let's take a look at it. 2 to 4, 4 subintervals. So we got 2 units to work with, dividing it 4 times, so it's a half. Each one is a half wide and is 4. So let's go with it. So if it's a half, that means it's going to be split up like this. Okay, half. So each of these is a half. It basically makes this x sub 0, x sub 1, x sub 2, x sub 3, x sub 4. Okay? Y'all see that? Alright, so what RAM are we doing? LRAM. So LRAM, we go up on the left, we hit. Boom. 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 Now for your test, you have to realize that this area that we're calculating right here is lower, it's less, because you see this gap? So we got negative area here. We got negative area. So that is going to make this summation a lower sum, or a lower approximate. Okay, so let's go ahead and calculate it. Since this is LRAM, we actually start with the x sub 0 instead of the x sub 1. So how do you shift 1, 2, 3, 4 to 0, 1, 2, 3? U minus 1. So all right, so let's calculate it. Basically 2 times this height times a half. Okay, so whatever it'll be times a half. So 2 squared is 4 plus 3 is 7. And then 2.5. Well, I know what 2.5 squared is. 6.25 times 1/2. All right, and then 3 squared 9 plus 3 is 12. plus 3.5 squared, so I gotta do that. Yeah. 3.5 squared. Alright, so 12.25. Oh man, did I forget to add the 3 again? I sure did. Okay, so mark that out. Mark that out. Well, I did add the 3 on that. I did add 3 on that, so that's good. And then 12.25 plus 3 is 15.25 times a half. So let me rewrite this because this is wrong. Okay. 7 times 0.5 plus 9.25 times, can't make up my mind, 0.5 plus 12 times 0.5 plus 15.25 times 0.5. Okay? Now watch what I do right here. It makes it so much easier. It's awesome. Okay, so bam. I just factored out a 0.5. 7. That makes my decimals a lot easier. I just combine these two. 9, that's going to give me 24.5. That's going to give me 19. Okay. All right. You don't have to do it like this. It's so much easier, though. So 19 plus 24 is 9, 4, 13. So 33.5, 43.5. And half of that is equal to 21.75 units squared. Oops, I just marked through my answer. There we go. Much better. Mark all the way through it. All right, so hopefully this helps with your LRAM. All right, moving on. Now we got the TRAM. All right, this is what gives people the most trouble, but that's okay. We can do it. All right, so we got TRAM trapezoids from 0 to 12, 3 subintervals, same as quiz. Delta X is 12 divided by 3 because we got it 12 long, 3 things, and N is 3. So first we're going to draw our trapezoid. So basically, delta X is 4. So basically, you're going to come up here. You're going to come up here. You're going to come up here. You're going to create trapezoids. And I don't have a straight edge. I wish I did. Better if I did. Rustle something up. Okay. So, all right. See if I can connect these really nice. Okay. Okay. My curve is not doing very good right here. Eh. Eh. Okay, that's not really a curve. It should be more curved. Oh boy. Yeah, my trapezoid, my curve right there is struggling. Should look more like this. Continuing curving, like so. Okay, so there are trapezoids. All right, trapezoid 1, 2, and 3. All right, y'all know that this is 1/2 base 1. So this is x sub 0, x sub 1, x sub 2, and x sub 3. Okay, so it's base 1 plus base 2. So basically that's the f of I plus the f of x of I minus 1. The f of x of I plus the f of x of I minus 1. So f of x of I plus f of x of I minus 1 and delta x. Okay, I'm going to replace delta x with, and I really should have done it on the rest of them too, so you should really write the delta x, because the delta x is right here. What was the delta x? It was 0.5. No, it was 1. Okay, put your 1 in there. And then this one was 0.5. And then this one was 1. Okay, yeah, sorry about that. You get in a rush sometimes. So this delta x is very important. That's 4. Now I'm going to do something really crazy right here. I know I got a ditto sign. I'm going to mark that out. So I'm going to go over it again. I equals 1, 3. Watch what happens here. This 4 and this 1/2, they can come together right now and make 2. Okay? Commutative property. It doesn't matter how you multiply them. You can just flip-flop it. Flop the 4 over there. All right? So f of x minus 1. Y'all know the commutative property. That's old school. All right, so there you go. Bam. All right, so basically I'm adding up the I minus 1, which is the 0, which is 3, and the f of x of I, which is 4, and 4 squared. I didn't write the function. All right, 4 squared plus 3 is 19. Okay, so this is 2 parentheses 19. Well, it's backwards. That should be, yes. No, I'm good. Yeah, 19, and then plus that one, which is the 0, so that's 3. Plus 2 parentheses. This next one is 5 squared plus 3 is 28. 28 plus 19 plus the other one plus 2 parentheses, and then the last one, 12. Oh my gosh, 144 plus 3, 147 plus 28. Okay, so there you have it. Now I'm going to do some funky stuff. I'm going to pull out a 2 because they have 2 in common. Okay, pull out a 2. And write 19 plus 3 plus 28 plus 19 plus 147 plus 28. And then, well, I could do some more crazy stuff, but I think I'll stop right there. Let's just combine 2. 19 and 3 is 21. 28 and 19 is 37, 47. And then 147 plus 28 is, I don't know, 167, 8, 67, 8, 75, 175, yeah. Okay, and then I'll add that up. 5, 7, 1, 5, 7, 6, 13. So 13, carry the 1. 3. Carry the 1. 1, 8, 12, 14. Alright, so 1, 8, 12, just don't type 12, 14. So 14, carry the 1, and that's 1. 1. Oh, did I carry the 1 last time? My battery just bleeped at me. I forgot. Yeah, I did. So that's 243. Okay, good stuff. So 2 times 243 is 486. So there's a look at all the work. Okay? And that's what you have for TRAM. And we are done, folks. Hopefully you do good on your quiz. Email me. Email with questions. Okay. Signing out.